what is a limit? A limit is a point on a graph that is approached on both sides. And then why do mathematicians use limits? So mathematicians use limits because they define continuity, t, derivatives, and integrals. And then, what is the difference between a function value and a limit? So a function value is f of x and is a closed circle on a graph. And then a limit would be an open circle on a graph. And then you find the value of a limit by looking at the open circle. That would be approached by a line on both sides.
So here we are determining limits by looking at graphs. And if we look at this first one with the equation of the absolute value of x minus 3 over x minus 3, the limit is getting closer to 3, we can see that these circles are empty and they're not filled, which means that there's no limit. So that this limit would be does not exist. And if we look at here, we have a limit getting closer to -9. The equation is 1 over x plus 9. And as you can see, it creates this sort of two-line thing. And since it doesn't get closer to anywhere and is approaching the y value in two different directions, the limit would not exist. So this would also does not exist. And we go to, as x closest to 1 with the equation x squared plus 5, we can see that 1's right here is on the parabola, which is what is formed with the function. And we can see that since we're finding the limit, not the fx value, as the point where it gets closer to each other, we can see that it gets closer to 1, and that means that this limit would be 1. So
I'm personally going to be explaining how to really approach limits from a table format. As you can see here, I just made a little table with a function that's supposed to emulate what it means to attack a limit from a table. So as you can see here, we have both sides of our table approaching a number, and obviously that number is 3. And as you notice up here, I have my limit of when x approaching 3 equals 40, because from these values down here, you can see from the 2.9 to 2.999, and x is slowly getting closer to 40, which would be at 3, and from 3.001 and 3.1, it's continuously getting lower from around 41 and getting closer and closer to 40. So for this table up here, we would have the limit of for when x approaches 3 be 40. However, there's also another way to figure out for when approaching a limit on a table can also not exist or be incorrect. Now, for it not existing, that's something similar to an asymptote, which will basically have me turn every value on this side of the table negative, and that gives me a little asymptote-ish graph if you want to do that out. But just know that this usually looks like something like this. Where it's always one value is going to positive infinity, the other value is going to negative infinity. Another time where the limit wouldn't exist is if I had a random value here in place of that 4. For instance, that 3 I mean, rather. For instance, that 3 could just equal 26, and that would really just be a closed value down here when our limit should be somewhere up here. So basically that 26 is the closed function value that is not a limit for this table. That's just the value for when f of when x equals 3 for f of x, not the actual limit that's being approached from both sides.